So this case study forms part of our work under the 9.1 in Work Package 9, so the importance of crop diversity and sustainable intensification strategies. We have one other paper, which is a case study of Uganda, but today we're looking at Kenya. So I'll just do this. Right. Okay, so clearly the backdrop here is one of sub-Saharan African countries, and Kenya is no exception, as we heard from Willis yesterday. Extremely vulnerable to climate change and climate variability, and as the same Willis has pointed out to us yesterday, that now there's been a 2-month drought going on in the main rain-fed areas of Kenya this year, which is obviously quite worrisome for this year's food production, particularly maize. And Kenya is strongly exposed to changing climate patterns, but has also several agroecological zones. So what this study is looking at is how climate risk has affected maize intensification and diversification of production, and making a distinction between weather versus climate as explanatory variables. And then taking into a second stage, looking at how intensification and diversification decisions relate to the income vulnerability, focusing on smallholder farmers. The sort of theoretical model on which this study builds dates back to some work that actually David Zilberman has been involved with together with Richard Just back in the early 1980s. But essentially taking a portfolio management approach to the decisions that farmers take in terms of especially crop portfolio or sort of crop diversification in their management decisions. And the main assumption that guides this type of framework is that a farmer will prefer a higher mean but a lower variance of returns on the decisions regarding the mixture of crops that are chosen. So it's an extension of the classical mean variance portfolio framework, but now also to include downside risk aversion in the form of the second moment of returns to agricultural production, so the skewness. And in this case, crop diversification becomes used, possibly can be used then as a buffer to cope with climate change, so and other risks, short-term weather as well as long-term climate change. So this returns to, I guess, part of the discussion we had yesterday around crop diversification and its role as a variable or as a decision variable. The data that was used for this case study is the reasonably well-known Tijumayo data set, which it consists of a household survey data covering more than 1,200 farms in Kenya over 8 different agroecological zones, but excluding the pastoral zone. So it's a data set that concentrates on smallholder crop production, but across the wide range of agroecological zones that Kenya does have, even for crop production. There's 4 rounds of this survey have been conducted, so it's quite a rich panel data set, and that leads to a sample size for most of the work in this paper of about 5,000 observations. So each farm observed over 4 periods. This is combined with climate data from the Climate Research Unit, extracted at the village level going back to 1971. And it takes account of differences in both the length and the timing of short and long growing seasons. What's Perhaps even more interesting from the data point of view, and the data that's been integrated in this analysis, is the use of a newer, more advanced drought index, the SPEI, which incorporates, in contrast to indices that even multi-scalar drought indices that were based primarily on precipitation and temperature patterns in the past. This also includes potential evapotranspiration, which is the E, so that adds quite some additional information to this variable, because it accounts for how much is expected that the moisture or precipitation that falls, how much is actually left for crop production. And there's also soil quality data that's been integrated into this. So the empirical approach is a two-stage procedure following the Mundlach-Chamberlain method. So it's a pseudo fixed effects, as it's sometimes termed. In the first stage, it's the intensification and diversification decisions of the farmer that are treated as endogenous. So in the first stage, those are estimated, and then the fitted values are used in the second stage to see how intensification and diversification of production affect the three moments, or so the mean of farm revenues, the variance in net revenues, and their skewness. So I'm just showing you an extract of the most relevant and interesting part of each of the two-stage estimations. I mean, bear in mind that there's somewhere between, I think, 20 and 30 explanatory variables in most of these in these regressions, but I'm cutting that off so we can just look at these results. So in the first stage, we have two variables, dependent variables representing intensification. That's the first two columns. So the extent, the amount of hybrid seed use is one, and the what's an intensity really of hybrid seed use, as well as the intensity of fertilizer use. And then diversification is represented by the Simpson index. If you're not familiar with that, it's actually the same type of metric. It's the same formula that's used for the Herfindahl concentration index in market structure studies. So it accounts for not only how many crops are being planted, but also the relative proportions of land that are devoted to each of these crops. So in a sense, it's a relative abundance measure from the ecological literature, and you can think of it sort of as equivalent to the market structure or market concentration index in industrial organization. One of the key results to look at here is in the far right column, that what we're seeing is that crop diversification appears to be driven by, is influenced by persistent climate shocks. So this drought frequency as the first explanatory variable represents long-term frequency of droughts, and that is a higher level of drought frequency is leading to decisions by farmers to diversify their crop portfolio more. Either they're adding more crops, or they're planting, or they're spreading it out. They're spreading out these crops more, this range of crops more evenly across their holdings. Then, if we look at the intensification decisions, we see also that the frequency of drought, so this long-term climate variable, is also having a negative effect on the amount of, or the intensity of hybrid seed use, as well, although not on the amount of fertilizer. On the other hand, the more recent weather patterns, which is captured in the way the phrase moisture that's been available in the previous year to farmers, is not only also having a negative effect on the decision to plant hybrid seed, but is positively correlated with the amount of fertilizer. The study also looks at, in a sense, at this long-standing discussion in the literature around soil and water management in Kenya, the so-called Bozzola hypothesis, in other words, which was originally proposed by Esther Bozzola, on the relationship between population and density in agricultural areas and intensification. And so here there are actually fairly clear indications of intensification being driven, because I think we can, given the identification strategy that's being pursued here, we can be fairly we can dare to infer some causality in these results. So population density is driving intensification as well. So this just sums up what I was saying. I guess to make it more clear, the farmers in the areas where weather is more variable, thus are tending to apply more hybrid seeds, but they're diversifying less. So if we move on now to the second stage regressions, and if you recall what I was explaining about that is now we're looking at taking the fitted values for these intensification and diversification variables, and we're using those as explanatory variables in net farm income, so crop revenue, its variance, that's the second column, as well as its skewness, which is the third column. And again, this is this is a very long table, of course, but we're just focusing on the main results. So, if to look at this carefully, I suppose what comes out, what's coming out fairly clearly is that hybrid seed use is positively affecting farm revenue. But interestingly, fertilizer use is not having that effect. We're interested particularly in this study in risk. So also what's happening with the second and particularly the third columns are of particular interest. And there's no evidence in this study that maize intensification is increasing risk, right? And applying mineral fertilizer is generally reducing the variability of agricultural net revenue. So that confirms what we would expect, has been seen in some other studies. The crop diversification is not having a significant impact on the variance of agricultural revenue. You can see that on the bottom of the second column, but it is positively correlated with the skewness. So it gives evidence that farmers they're responding to climate change by maintaining a higher level of diversification or even diversifying more in response to droughts. And this strategy is then ensuring that they have less downside risk, because positive, if your skewness increases, that means you're more skewed towards the top, so to speak. So it's you have less chance, there's lower probability of much lower income results. I think that's effectively, I've just explained the results to you. The contribution of this, just briefly, of this work, which at least from a methodological and data point of view, is partly the combination of both the intensification and the diversification decisions, including this use of the skewness variable, a very careful accounting for the very different ecological zones in Kenya, and a very systematic approach thus to dealing with unobservable heterogeneity, as well as the use of this new drought index, which is providing interesting results and allowing a distinction to be made between weather and climate change measures. And so that highlights how climate and weather are having different impacts on agricultural revenues, which we hear a lot of, but the systematic evidence is really only starting to emerge, and this is one example. So persistent climate shocks are leading to diversification choices to reduce downside risk, but more shorter-term weather patterns seem to be affecting the decision to intensify or use hybrid seeds more. So in terms of, if we want to try and make links between this and policy, it's difficult to take the results of this specific study and point to very clear policy variables. I would point out, that one variable that was looked at, which was credit, also tenure security, although there's been little change in that over this data set, but it's starting to. But certainly credit has having a positive effect on farmers' ability to intensify. So actions that would support smallholder adaptation to changing climate patterns and climate shocks would obviously seem beneficial, and also promoting knowledge formation among farmers concerning weather, climate, production, and post-harvest handling, as well as other adaptation strategies, would be beneficial. But those can't be specified in this study more precisely. But clearly, farmers are struggling to cope with these changes. And I'll leave it at that. I mentioned already the Bozzola opinion.